we're going to have a look at the discriminant. The discriminant is part of the quadratic formula. The discriminant is just the b squared minus 4ac part of the quadratic formula, so the bit under the square root sign. And it's called the discriminant because it discriminates between what kind of roots we have. If you look at this part of the quadratic formula here, a plus, minus. So we're adding on or taking away the bit under the square root sign. Now if that's greater than 0, which is the ones that we looked at in the quadratic formula, then we get two real and distinct roots. So we get two real roots that are different. If that's less than 0 under that square root sign, we get no real roots because we can't take the square root of a negative number. Or you can, but you need to study some further maths to get that understanding. So for our purposes, if that's less than 0, we get no real roots because we've got nothing we can add on or take away because it doesn't make any sense. If it's equal to 0, then we'll get the same root whether we add it on or take it away, because if you add on 0 or take away 0, it makes no difference. So if it's equal to 0, we get one real roots, which are sometimes seen as repeated roots or equal roots. Graphically, this is what that would look like. Two real roots. If it crosses your x-axis in two different places, that's what it would look like with a maximum turning point. That's what it would look like with a minimum turning point. If we had one real or equal roots or repeated roots, then it's touching the axis, it's turning on the axis. There it is with a minimum turning point, and there it is with a maximum turning point. If we've got no real roots, it means it doesn't cross the x-axis. So again, we can have maximum and minimum turning points, but it doesn't cross that x-axis at all. We also need to know whether or not our roots are rational or irrational. Very simple way to find that out. If we can take the square root, it's rational. If we can't, it's irrational. Okay, so let's have a go at finding the nature of the roots of a quadratic equation. Just to be clear, it's the nature of the roots we're looking at, not the nature of the turning point. So the nature of the turning point is maximum, minimum. Nature of the roots, you've got three options: two real and distinct roots, one repeated root or equal roots, and no real roots. Okay, very similar to the quadratic formula then. I'm going to start by picking out our A, our B and our C. So A is 2, B is 3, C is 1. Don't need the full formula this time. We're just looking at the b squared minus 4ac part. Putting in my numbers, I get 3 squared minus 4 times 2 times 1. 3 squared is 9, 4 times 2 is 8, times 1 is still 8. 9 take away 8. 9 times, why have I written times 8? Let's get rid of that. 9 take away 8, it's because I said time, that's what it is 1. Now, what we're interested in is whether this is greater to, less than, or equal to 0. This one is equal to 1. 1 is greater than 0. Therefore, 3 dots just means therefore, we have two real and distinct roots. You need to mention both things. You need to mention the fact they're real, and you need to mention the fact that they're both different or distinct. Looking at the next one, A is 1, B is minus 5, and C is 1. The discriminant is b squared minus 4ac. So we get minus 5 squared minus 4 times 1 times 1. Minus 5 squared is 25. Minus 4, 21. Still greater than 0. So we get two real and distinct roots. Let's try C. A equals 1, B equals 4, C equals 5. So b squared minus 4ac, so we get 4 squared minus 4 times 1 times 5, so we get 16 minus 4 times 1 times 5 is 20. So we get minus 4. Minus 4 is less than 0, so we have no real roots. And make sure you have the word real in there. I'm going to add in a wee extra example to show you one way that you have repeated roots, just so you get the wording of it. So let's go for x squared minus 4x plus 4 equals 0. So a is 1, b is minus 4, c is 4. So b squared minus 4ac minus 4 squared minus 4 times 1 times 4, which is 16, minus 16, which is 0. Therefore we have repeated roots, or equal roots if you prefer. Okay, another way we can use the discriminant then is if we get told what kind of roots we have, we can use it to find a missing quantity. So if we look at this one here, I've got x squared minus ax minus p. So a is 1, b is minus 8, c is minus p. This time I'm told it has equal roots. Because it's got equal roots, then b squared minus 4ac must be equal to 0, because we have those equal roots. b is minus 8, so we've got minus 8 squared minus 4 times a is 1 times minus p equals 0. Tidying that up, 64 plus 4p equals 0. I just need to solve for p. So 4p is minus 64, so p is minus 64 over 4, which I need in simplest form, which would be minus 16. Okay, I'll leave you to practice some of these.